Okay.
Okay. All right, everybody turn to section 10.1. It's on page 523. We are going to be taking pieces of this section over the next 2 days. Friday, we're going to go in detail over some of the homework to make sure that you have it and do a little review. And Monday, we're going to have a 50-point test on this section only.
What page, Ms. Silence?
523. Page 523.
Thank you, Miss Allen.
You're welcome, Mr. Champ.
What page?
I've already told you.
Darn.
All right. We're dealing with, y'all stop. We're dealing with exponential functions. Okay, the first thing we're going to be looking at today is how do you recognize, simply by looking at a graph, whether an exponential function has growth or decay, and then how do you look at the function itself, which is going to be the letters and the numbers that are involved in the function, and tell if it has growth or decay. All right? But first, let's talk about what is an exponential function. First off, remember that a function is a relationship between two things. All right? So there is an x and there is a y variable. We've dealt with linear functions. Y'all stop.
If I'm ADD,
I have to use this, okay?
okay. I'm done.
You want to start
Algebra
over?
2 class, take 2.
Take two.
No, that's fine.
Oh, okay.
Okay.
It's only been a minute and 47 seconds.
48.
49.
50.
We can just cut over
Thank
the
you.
first 2 minutes.
Yeah, I can edit.
Oh, you
Oh,
can?
man.
Awesome.
Yes. All right. An exponential function has two variables in it. It has x and it has y. And the reason it's called an exponential function is because one of the variables has an exponent. Is an exponent, excuse me. This is an example of an exponential function. The exponent itself is a variable. Exponential functions are graphed and look like this. Or this. Or this. Or this. Isn't that cool? Okay?
They don't cross that.
They do not cross the y-axis. An exponential function, this is an example of a function with exponential growth. As it starts on the left-hand side, it starts really, 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 really close to 0. It never hits 0. But if we were to actually remember, numbers go on forever. Okay?
Wait, don't you mean they don't cross the x-axis?
Yes, it doesn't cross the x-axis. I'm sorry. As your function approaches negative infinity, your y values they just keep getting smaller and smaller and smaller without ever hitting 0. So if I had 0.1, what can I do to make it smaller but not get to 0? 0.01, and I could keep going, 0.001, and forever I could keep going. Okay, so we couldn't actually physically represent that with a picture because eventually our line's going to touch. But understanding that numbers do go on forever and we could get smaller forever. This, and as it goes to the right, it is growing. Your y values are increasing. This is a function that represents exponential decay, which means as our x values are increasing and approaching infinity, our y's are getting closer and closer and closer to 0. An exponential decay starts big and gets smaller. Exponential growth starts small and gets bigger. Does everybody understand that? Okay. These that are on the bottom of the x-axis are simply a reflection of these two functions based on the sign of this number. Okay? If this number is negative, instead of the function being above the x-axis, it would actually reflect and flip over below the x-axis. So this function, even though it's approaching negative infinity here, it is a reflection of your growth function. Because of the sign, we wouldn't actually call it growth because it's not growing, but it's a reflection of a exponential growth function. This one is a reflection of an exponential decay function. It simply reflects about the x-axis. And what's that based off of?
The negative.
The
The
sign.
sign of the number. Okay, now we're going to be using terminology here whenever we explain how to tell if you have growth or decay, so I want you to make sure you understand it. This, what's that?
Is it a sign of Y and sign of?
The sign of this base is what it's called, okay? This is called your base. It is the base of x. Remember, x is an exponent. The base in this function tells us whether it has growth or whether it has decay. Now let's look at how we know the difference. Today we're not going to be graphing functions. We're simply going to be recognizing whether it's growing or decaying.
That's it?
Tomorrow we're going to be graphing. All right. Exponential decay occurs when the base of x blah, 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 is a value that is between 0 and 1. So what kind of values are between 0 and 1?
0.1.
Fractions, positive fractions, okay? Or decimals that don't have a whole number. Examples of what that would look like. Now let's think about this. Why would this show decay? Why, as x would be increasing, getting bigger, would y be getting smaller?
Because when you multiply anything by a fraction, you're really dividing.
Because when I square a fraction, what happens when I square 1/2?
All it is, 1/4.
You get a
I
smaller
get
number.
1/4. I get a smaller fraction. When I cube, even though x, the value of x has gotten larger because now it's 3, the value of y is now
1/8.
1/8. Okay, it's getting smaller and smaller and smaller. So this is an example. This would be an example of exponential decay. It is a decimal, but this decimal represents the fraction what? 2/10 or 1/5. As I square it and cube it, it's simply going to become a smaller and smaller and smaller decimal.
Is 0.2 times 0.2 0.4 or 0.04?
0.04. Because remember, when you multiply two decimals, you've got to count all the decimal places.
Right.
Okay? All right. This says you have exponential decay when the base of your exponent is between 0 and 1. What is the base of the exponent in that function? 1/3. Not the 3. The 3 we're going to learn tomorrow tells us something completely different. The 3 is where this function crosses the y-axis. This is our y-intercept. This number tells me whether it is growing or decaying. Okay? So here, even though I stuck a number in front, that doesn't matter. It's the base of the exponent that tells me what direction the function's going in. All right, now let's talk about growth.
If it's 1 to whatever power, it's just a line.
If it's 1, notice, this says between 0 and 1. Not equal to 0, not equal to 1. And we're going to talk about growth in a second, and you're going to see again it's not equal to 1. And I'll show you why.
Okay.
All right?